How's it, guys? Welcome back. Hopefully you're still enjoying the show. Thanks so much for staying tuned. We have one final question from Philippine. She's struggling with some 3D trigonometry, so let's check out her question.
Sup guys, I'm Dylan, and bro, this question, oh, it's a really tough one. So as you can see, that's what we're trying to work with. Oh no.
Yo guys, that's my bad. That was Dylan. I'm so sorry. I dealt with Philippine's question earlier. So Dylan, this is such a great question. I love this question so much because it's so 3D and it helps me help you guys so much with your 3D stuff. So let's jump right into it. It says, from a point Q at a Navy base, two passing jets S and T are observed. Well, check me out. P and R are points on the ground directly beneath S and T respectively, and in the same horizontal plane as Q. The angles of elevation of S and T from Q are alpha and beta respectively. In addition, angle RPQ is 90 degrees and angle PQR is theta. The height of S above the ground is given as h meters. Okay, so guys, the reason I love this question so much is because we're asked to find one length, but we have three separate triangles that we're working with. And based on what we have to prove, we're going to have to use all three triangles, which is like, it's hectic, guys. So this is such a great question, but it's going to help me help you understand your 3D stuff. So let's jump into it. It says, prove that TR is equal to h tan of beta over tan of alpha multiplied by cos of theta. Okay, so TR is this length here. But if we look at what we're required to prove, we need to use h, which is over here, beta, which is over here, alpha, which is over there, and theta. So we're going to have to use all three triangles found in this question, guys. So if I look immediately, we have this triangle here. We've got right angle there, P, S, height h given there, alpha given there, and Q over there. So automatically we have a lot of information given in that triangle, guys. Then the next triangle is the one in the middle that we can see here. There's a 90 there, P is there, R is there, Q is there. We're given that that angle there is theta, and that's all we're given in that triangle. So immediately I look for common ground. PQ is there and PQ is here. Okay, and the final triangle is this big one over here. We have a right angle there, T, R, and Q. We're given that this angle here is beta, and that's all we're given. So common ground, guys. We can see that RQ is common to both triangles here. Okay, so because we've got the most information in this triangle, I want to start there. We're given an angle, we're given the opposite side, and we're trying to find the adjacent side. So immediately, tan of alpha is equal to the opposite side given as h over PQ, which means that PQ is equal to h over tan of alpha. Okay, so now we can go immediately to this triangle and say that that side is h over tan of alpha. Okay, so now let's work in that triangle there. We've got the adjacent side here. We're looking for the hypotenuse, so it is sine of theta is equal to, oh wow, I'm lying to you guys. Adjacent and hypotenuse is cos. So cos of theta is equal to adjacent over hypotenuse, which is what we're trying to find. Therefore, RQ is equal to, let me check this out, h over tan of alpha multiplied by cos of theta. Okay, so immediately RQ over here is h over tan of alpha multiplied by cos of theta. Okay, so now we can finally work in this triangle that we've isolated over here. We are looking for, in that triangle, we are looking for TR. Okay, so that is the side opposite the angle beta, and we've just found an expression for the side adjacent. So again, we're using tan. Okay, so tan of beta in that triangle is equal to the opposite, which we just found, is h over tan of alpha multiplied by cos of theta. Now remember, that's only one side. We need to say over the adjacent side, which is RQ. Wow, I'm lying to you guys. Okay, so the opposite is what we're trying to find. Let me erase this here. The opposite is that TR that we're trying to find, okay? And the adjacent is the stuff that we just found that huge expression for. So that's h over tan of alpha multiplied by cos of theta. Okay, so now we're getting somewhere. Now, to solve for TR, give me some more space here. We need to multiply by this entire denominator. Okay, so TR is equal to tan of beta from the left-hand side multiplied by h over tan of alpha cos of theta. Okay, so if we just rewrite that out, h tan of beta all over tan of alpha multiplied by cos of theta. Let's check what we had to prove. H tan of beta over tan of alpha multiplied by cos of theta. Perfect. That's exactly what we needed to prove. Okay, so guys, I'm really, really grateful that you guys sent in this question because as you can see, they gave you 3 separate triangles, but they just didn't give you enough information in 2 of them for you to be able to solve for the one that you're looking for. Okay, so more often than not, when you have 3 triangles that look like this, you're looking for one side of one triangle. If they give you 2 other triangles, odds are you're not going to be able to work with the triangle that contains the thing you're looking for. Okay, so you need to try and look. My first advice is to look for 90-degree triangles because then immediately you can start using trigonometric ratios. Try and find expressions for common sides. Look for common sides, guys. The moment you have triangles in different planes, odds are they're going to share an edge. Try and find expressions for those edges so that you know exactly what you're working with. Okay, so this has been a really fantastic question. It's so 3D, it's so involved. I'm so glad you sent this in. Send in others like this because we really, really want to help you with your trigonometry. That is our last question for the day, but we have a fantastic career video, guys. This shows you how trigonometry is applied outside the classroom. So have a look at this video, it's fantastic, and I will see you after that.
My name is Liam Williams. I'm from Cape Town. I'm a captain on Embraer regional jet fleet for Airlink based in Cape Town. My inspiration for becoming a pilot was seeing my uncle fly. He used to fly microlights and just going up in the air with him and really enjoying it. And I've always had a sense of adventure and I enjoy all the challenges that come along with flying, which I hadn't quite discovered yet in the early days. But I started out and just began to enjoy the sense of adventure and the life challenges it brought me. With our company, we have 3 different versions, a 37, a 44 and a 50-seater jet. So it's a medium category aircraft and we do regional flying around Southern Africa as a commercial airline. So with Airlink, we have 3 bases in South Africa. We have Johannesburg, Cape Town and Durban. I'm based in Cape Town, and from Cape Town we do Cape Town to Windhoek in Namibia, Maun in Botswana, Victoria Falls in Zimbabwe. We do Skukuza in the Kruger Park and Kruger Mpumalanga International Airport, and then also do smaller regional routes, Kimberley, Uppington and George. The process to becoming a pilot would be to join a flight school. Once you join a flight school, you'll sign up and begin a schedule depending on your time availability and go through the process of flight training. You start out by doing your private pilot's license, where you need to do practical experience of 45 hours, where an instructor will take you and teach you from beginning to the end of that process. You'll also write several exams, completing the theoretical aspect of the private pilot's license training. Once you've completed that, you continue on towards your commercial pilot's license, there's further theoretical subjects to write. And further flight training, you need a total of 200 flying hours. My first flight as a qualified pilot was for Skydive Cape Town, taking skydivers up and seeing them jump out the aircraft, which was quite interesting. And my first job was for a charter company based in Polokwane, and we used to fly in and out of Botswana mostly. And I really enjoyed the freedom and the experience of being free and soaring in the skies and showing people the kinds of views you get and taking people to beautiful places. Maths and science is important as a commercial pilot. It forms the basis of all the theory you do in all the various subjects, the basic formula of lift that you'll work through for an aircraft to actually fly. You work through that in your foundational phase of training. Through all your theoretical subjects, you do calculations, calculating the mass and balance of the aircraft, calculating navigation. And then from a day-to-day basis, we're calculating baggage. We have certain limits in all aspects of the flight that the aircraft is capable of flying in, so we need to calculate the weights, calculate how much fuel we need to get to our destination, making sure we can carry enough and that we don't fly an aircraft that's overweight in terms of passengers and the baggage. So there's constantly calculations for every takeoff. So trigonometry forms part of aviation in many aspects. The major one would be our en route navigation. The wind blows from particular directions and we have a certain track to follow, flying from point A to point B. And we need to maintain the track, and the wind drifts us off that track, so we need to adjust our heading. And then we'll calculate the drift angle so that we fly the correct heading, so that we stay on a particular track to our destination, and not doing that would set us off course. Another very important aspect using trigonometry, which is our final approach path angle. Generally we have a 3-degree slope that we fly down, which brings us at a suitable speed and rate of descent down to touchdown onto the runway, and that's calculated at a specific, from a specific height at a certain distance all the way down to touchdown. So it's very important we stay on that path. Getting too low could be quite dangerous, getting close to the ground when we're far away from the airfield. And if we're too high, we might not be able to land, and then we're going to need to go around and attempt to approach again. So those approach angles are very critical. The most exciting thing about my job is the freedom of being in the sky. The views you get, the quietness of being above the clouds. It might be quite a dark day downstairs underneath the rain, but once you're above the clouds, you're in the sunshine. Sure, there's times when you're in the weather and you need to negotiate it, but just to feel that sense of freedom above the earth is a very thrilling sensation.
Yes, guys, thanks so much for tuning in again to one of our fantastic episodes brought to you proudly by Liberty. Don't forget to send in your questions for factoring polynomials next week. We really want to get you engaged. You could win a TV, guys. Engage with our app, engage with our show. Check us next time, that same time tomorrow, and we'll see you. Have a great evening.